Hey there. This is your cloud mentor, Girish on Effort. Today we are dealing with different types of intermolecular forces. And at the end of the video, we will discuss a question from JEE. While we talk about intermolecular forces, or in short IMF, are the forces which mediate interaction between molecules, including forces of attraction or repulsion which act between molecules and other types of neighboring particles, for example atoms or ions. Intermolecular forces are weak relative to intramolecular forces, the forces which hold a molecule together. For example, the covalent bond, involving sharing electron pairs between atoms, is much stronger than the forces present between neighboring molecules. Both sets of forces are essential parts of force fields frequently used in molecular mechanics. There are specifically three types of intermolecular forces. They are dipole-dipole, ion-dipole, and ion-ion interactions. So the first one is dipole-dipole interactions. Dipole-dipole forces are attractive forces between the positive end of one polar molecule and the negative end of another polar molecule. Dipole-dipole forces have strengths that range from 5 kJ to 20 kJ per mole. They are much weaker than ionic or covalent bonds and have a significant effect only when the molecules involved are close together, whether touching or almost touching. The figures show two arrangements of polar iodine monochloride (ICl) molecules that give rise to dipole-dipole attractions. Here we can see the interaction between positive polar end of this molecule with the negative polar end of the other molecule. A dashed line is used to represent an intermolecular attraction between molecules because these forces are not as strong as chemical bonds. And the next one is ion-dipole interaction. An ion-dipole force is an attractive force that results from the electrostatic attraction between an ion and a neutral molecule that has a dipole. Most commonly found in solutions. Especially important for solutions of ionic compounds and polar liquids. A positive ion, cation, attracts the partially negative end of a neutral polar molecule. A negative ion, anion, attracts the partially positive end of a neutral polar molecule. Ion-dipole attractions become stronger as either the charge on the ion increases, or as the magnitude of the dipole of the polar molecule increases. So the next one is, ion-ion interaction or ionic bond, also called electrovalent bond, type of linkage formed from the electrostatic attraction between oppositely charged ions in a chemical compound. Such a bond forms when the valence, outermost, electrons of one atom are transferred permanently to another atom. The atom that loses the electrons becomes a positively charged ion, cation, while the one that gains them becomes a negatively charged ion, anion. And this is the strongest of all other interactions. Now, moving on to our question. The relative strength of interionic or intermolecular forces in the decreasing order is, A. Ion-dipole greater than dipole-dipole greater than ion-ion, B. Dipole-dipole greater than ion-dipole greater than ion-ion, C. Ion-ion greater than ion-dipole greater than dipole-dipole, D. Ion-dipole greater than ion-ion greater than dipole-dipole. So now we know, the answer is C because, ion-ion interactions are stronger, since they have stronger electrostatic forces of attraction, whereas dipoles have partial charges, and hence the electrostatic forces in their case would be relatively weak. So, that's all for now.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.